to build secure containers.
Yeah, there we go.
My name is Diogo Monica. Hi, welcome to our Docker security mini-series. Today, we're going to be talking about how to build secure containers. My name is Diogo Monica, and I'm the security lead here at Docker. Before we go into nitty-gritty details, let me give you some general tips on Docker files and Docker file security. The first thing you need to do is you need to consider how to verify the authenticity of any software you install in your images. In the case of using some official apt-get, for example, you can have and be sure that this has been taken care for you. However, if you are downloading files from the internet or installing software from a third-party repository, you should always verify these files are signed or have valid checksums. For example, if you are adding a file remotely, you should make sure that this URL is using HTTPS and not HTTP. If you're using a third-party repository, you should always include the right GPG keys before using your package manager to update these packages. You can even pin to specific hashes of a file to ensure that these remote files have not been maliciously modified. Another recommendation is on your from directive, you should always use a specific tag. From Ubuntu 14.04. Not just from Ubuntu. You should never run your applications as root. Just because you're using a Docker container doesn't mean that you can ignore 20 years of best practices of Linux security. In fact, you should always use the user directive inside of the Docker file to make sure that you drop privileges of your user. If your application has to start as root because it runs on a privileged port, remember, you can map arbitrary ports on your host inside of the container, so you don't actually need to run with the same port inside of the container as you do outside. If you do actually need to run as root, not because of the port, make sure that you drop privileges as quickly as possible. One recommendation on that is use gosu and not sudo. Now let me talk to you about minimal base images. What is a minimal base image? A minimal base image is a Docker image that has no cruft. It has the minimum essential things that you need to run your application successfully. There are several different minimal options. My favorite minimal image is Alpine. Alpine is only 2 megabytes of image compared with, for example, Ubuntu that is around 60 megabytes. There are obviously trade-offs between minimal images and bigger images, such as the availability of packages, but in general, you should always build the minimum image that you can to run your application. Remember, do not run SSH inside of your container. There is no reason why you should need it. And now I would like to run through a demo of us building our own Docker file that builds Nginx in an Alpine minimal image.
The first thing we need to do to create our Nginx Alpine image is to create a Docker file. Inside of this Docker file, we're going to use the from primitive to provide what base image do we want for our Docker file. In our case, we're going to use the minimal base image Alpine with the 3.2 version. After that, we're going to run Alpine's package manager, and we're going to add the Nginx package. Also, we're going to make sure that we remove the cache in order not to create an extra layer. Now, we're going to finish our Docker file with our commands, which will be what Docker uses to run this image. We're going to make sure that we provide daemon auth, or else this won't work. And there we go. So now we have to add an index.html and an Nginx configuration. If we leave the Docker file, you'll see that I provided index.html with a nice Nginx running message and a very simple Nginx configuration file out of the box. This listens on port 8080. So if we go back to our Docker file, we can add these files to our image by using the command copy. Let's add nginxconf to add c.nginx/nginx.conf, and let's add our index.html to user share nginx html index.html. And that's it. At this point, we have an Nginx on top of the Alpine in a Docker file that should build. Let's try it out. Docker build, call it Nginx, and let's run this. This should be incredibly fast. because the Alpine base image is really small. We're actually going to see that the final image with Nginx is going to be under 7 megabytes. I can show you that by running Docker images and showing you that, in fact, our image has 6.7 megabytes. That's great. So now let's run our Nginx. We can do that by doing docker run. We're going to bind the 80 port on the host to 8080 in the container, and we're going to run Nginx. And if we go to our browser, we're going to see that we now have an Nginx running inside of an Alpine Docker container. This is great. Unfortunately, our Docker file did not set a user, and so Nginx is running as root. I can show you that by running the same Nginx in daemon mode, and then we can actually execute a ps command inside of this running container to show you that even though the process worker is running as Nginx user, the master process is running as root. Okay, we can do better than this. So let's kill our container by doing docker kill. We're no longer running it. And let's edit our Docker file to add the user directive and say that Nginx should actually be running as nobody. Okay. Unfortunately, Nginx needs to be tweaked to be able to run as non-root. And so I provided another configuration file, nginx nonroot.config. The only differences to the other configuration file are the fact that we're setting the log error in the PID on temp, which is a directory that does not require root privileges to be written to. And we're setting an array of cache files that would otherwise be set to restricted locations that are only accessible by root. Okay, so if we added our Docker file to, instead of using nginx conf, to use nginx non-root conf, and we rebuild it, we should be able to see that this container is no longer running as root. And Nginx should in fact be running as nobody. Let's try it out. Docker run -d with a port. Container is running. Our website is still running. And if we do docker ps and we do docker exec of this running container with ps, you're going to see that in fact it is running as nobody. So here you go. This is an example of how from scratch you can create a Docker file that has Nginx on top of Alpine running as non-root.
Thank you so much for watching the video today. Make sure you go to docker.com/security if you want to learn more.
All right.
Ben, a request has been made to give us the URL in the email mailing list.
Yeah, it's going to be. I've already got the URL copied into my presentation, so
Thank you.
will all be provided. Glad you're all able to hear that. All right, so let me switch to my presentation. Yeah, here we go. Okay, so can you all hear me?
Yes.
Still? Okay. All right. So I've been looking all around and exploring Docker security mainly because I want to be sure about something before I dive into it, and so I'm kind of doing it backwards from what everybody else is doing about Docker. Usually, people just jump into Docker and start building things, and then finding out that they got security problems later on, and I'm just refusing to do that because I want to know all the bad stuff before I jump into the pool. I've been I was going to give this presentation off of my my trusty little stenographer's notebook, but as I was presenting to you guys, I had to make a PowerPoint presentation, so I made it pretty basic, and hope you'll forgive me. But this is what I've collected from random security conferences on the internet, and so let's dive in. Okay, so this is basically security 101. If you're managing a server, and whether it happens to be a container or a VM or a physical host, you got to be guided by the principle of least privilege, which is don't give the processes that you're running your web server as world authority. You just give it enough privileges to run the application, and that's it. And if you have to start on a low number port, then you do that, but then drop privileges as quickly as you can, and then start another process using that port.
Hey, Ben?
Yeah, hey.
Are you on the second page of the slides?
Oh, shoot. Hold on. No, I was okay. I went back to the title page. Can you see that?
I see the title page, yes. Okay, go ahead.
Are you seeing Docker security tips?
Yes.
Okay, all right.
I thought you were already on Security 101. Go ahead.
Okay, now I'm on Security 101. It should pop up for you momentarily. So yeah, this is just basic stuff.
I don't see it.
Not yet? Okay. Hold on. Let me get out of full tilt boogie here. And
there we go.
Can you see that?
Yes.
Okay. I don't remember having problems with Chrome like this before, but I'll just leave it like that. Sorry. So yeah, this is just basic security stuff. Don't run as root. Keep your certs locked down to read only by root, with no other privileges for the group or the world. Don't have any privileged containers that can do stuff, because that kind of defeats the purpose of having containers in the first place. Your config file should be owned by root with 640 permissions, and don't run on privileged ports. And if you do, then you're going to have to drop privileges quickly. But the trick to Docker is that you can run a web server on port 8080, and then just redirect the main port 80 to 8080, and then that'll be your that's the way you can make it secure. All right, transitioning to Security 101 continued. Use the Linux kernel capabilities, which is use SC Linux to run your server. Dan Walsh has been running up and down the world trying to promote SC Linux for the last 8 years now. Apparently, a lot of sysadmins are still finding it to be a chore to implement, but
breaks a lot of things.
Yeah, and it still breaks a lot of things. So, but that's one of the recommendations.
We have a question.
Get that working, then great. Yes.
Yeah, when you say use SC Linux to run your server, do you need your host operating system?
Are you saying SE Linux on the host or on the guest?
No, on the host.
Thank you.
Yeah. Okay. So use the user limits program, ulimits, that will lock down your processor and your memory limits to something reasonable because containers are just like processes. If you give them full run of the box, you can have a runaway container just like you can have a runaway process, and you can eat up all your memory. And if you got 10 containers running on the same box or the same VM, then one container can kill all the others by using up all the memory and CPU. All right, so don't share namespaces. Namespaces is a kernel capability, like C groups, that containers are able to use. And by default, Docker runs with the same namespace for all containers, and that's a bad thing if you want to separate what one container knows from another container. And it kind of falls in line with what Dan Walsh says about containers, that namely containers don't contain. So that is something that you have to manually configure. Yeah, so that's all I'm going to say about that. Don't mount etcproc or dev file systems that containers should not know about. The only thing the container is sharing with the host operating system is the kernel itself, and all the libraries and everything that it needs are packaged inside the container. So that's what makes it useful and portable and able to move from one host to another easily, as long as the other host has the same kernel running. Mount the root file system read only. Who is? I mean, this is just good stuff to do in general. I'm wondering if does anybody there run their servers with the read only root file system?
Everyone's got strange.
Yeah, okay. Well, you shouldn't be doing that.
I don't mount the root file system, but when I can, I mount other things read only.
Glenn was saying he mounts other file systems read only, but not root.
Okay, all right, that's fair enough. I mean,
you don't mount root at all?
I don't know what
Slash.
Well, you'd have to root. You would have to mount root in some way. I mean, I'd like to see it if you didn't have to mount root.
Guess what I'm saying?
But
in my Docker run command, I don't miss root.
In the Docker run command.
Oh, okay.
So you're talking about.
All right.
You're talking about mounting that inside the Docker file read only. Ben, is that what you're saying? Within a container?
No. I collected this from talk on the internet, so I'm pretty sure the guy was talking about mounting root file system read only on the host itself. So
Really, it's probably a good.
But I could be wrong. I mean, that would be a really secure system. I mean, but you could only you would have to unmount the root file system as read write, remount it as read write, and then make your updates, and then mount it back read only. And that would be simple enough to do in a script, I guess. So yeah, that would be a pretty way to run a secure host with a bunch of containers on it. As always, you got to have a backup of your system, and preferably not in the same place where you're physically located. The standard HIPAA requirement is that your backup location has got to be 100 miles away from your current data center.
Ben, we got a question.
Yes.
I mean, if you did that, you're going to have to put like temp and other things like on their own partition here.
Yeah, you would.
It's not going to run.
Yeah, you would certainly have to mount var and other like temp, like you're saying, as read write.
Also, like,
Yeah.
it would be very scary, but very inconvenient, you know?
It would be very inconvenient, especially when you're doing updates, when you're patching.
Yeah.
You'd have to.
Well, we're running the same old security problem of compromise between convenience and security.
Security and convenience.
So very obviously, that's just part of monitoring, and you should be logging to a central location if you're any kind of decent or decent sized enterprise, and you'd want to read the logs, of course. So make sure you do that. Moving to the next slide, getting into more specific things about the network. Use transport layer to the registry, because if you don't, if you just use a link to your registry, then obviously the image that you're getting is not going to be the image that you thought you were getting. Make Docker use the network stack if you want to take advantage of the cool kernel features like the host firewall. If you just use domain sockets, then it's not going to be able to take advantage of the IP tables. It'll be twice as fast, but you just won't have that security. So that's a trade-off. Like the guy said in the video, don't put SSH in your container. It's kind of neat when you first build a container that you can SSH into it, but then you kind of realize, oh, wait a minute, I can SSH into my container, and that's not the best thing. Yeah, I do it one time just to see it, and it's neat. But then go ahead and take it out, rebuild the image and then rebuild rerun the container. Listen to loopback only. If you put Docker listening on a network port, then you're going to expose it to all kinds of bad guys that can connect to that network port. So that was a pretty good recommendation, I thought. All right, moving to the next. The images again. And what I liked about that presentation was the guy was using just a tiny 2 megabyte Alpine image, and adding Nginx only added 5 megabytes to it. Like the Marines say, you can take all you can eat at the chow line, but you got to eat all you take. So if you get a 700 megabyte Ubuntu image and make a container out of that, then that is a whole bunch of applications to be eaten, and you got to protect them. So it's going to be a lot more difficult than a 2 meg Alpine image. I should also mention here that there's a distribution specifically made for containers where everything is run as a container, and that just came out recently, maybe 7 months ago, called Rancher OS. And it kind of falls in line with Jace's presentation about infrastructure, about how you want to be herding your containers like cattle instead of caring for them and loving them like little pets in your house. Because you can herd a whole bunch of cattle, but you can only take care of like 2 or 3 cats. All right, so maintainability of your containers. This is just the same deal of you don't want to have 20 different kinds of images in your image repository. 3 would seem to be ideal, for the Goldilocks scenario, or small, medium, and that's just based on size of images. But actually, you would really want to go for a minimal image that is just super customized just for running the Nginx server, or if you had a persistent external data store, then you could have an image specialized for running, or yep. Hold on. I'm about to lose my computer because
Hey, Ben, that last little bit's been jumping in and out. We can't quite hear what
All right, hold on. I had to. We got to plug in power cord. All right. I'm good now. I think I am. Yeah, we're good. All right. Maintainability. So yeah, three to five images should be good for your enterprise. You want to. Oops. Okay. Can you all still hear me?
Yeah, we can hear you.
Okay. All right. Can you still see the presentation?
Maintainability.
Okay. All right. There we go. One thing that I thought was interesting is there was a guy named Mortman who was referenced at the end of the presentation that recommends just running one container per VM. And I can see that because the VM would provide the security. VMs are pretty secure, a lot more secure than containers are. But he's using the portability of the container to be able to move it from one VM to another easily. No chef or puppet. You don't want to be managing your containers with these tools because you don't want to be changing the bits and bytes of your containers on the fly. You just want to change the underlying image and restart the container. That's the way to go there. SecComp is a program that reduces the kernel's attack surface, and you want to use it. It eliminates the system calls like syscontrol and sysfs and kexecload and a whole bunch of others I didn't list there. It blocks 32-bit system calls and blocks old and weird networks. That slide I got from Dan Walsh, so I got to give him a shout out on that one. He's Mr. SE Linux, works for Red Hat. And a couple of the miscellaneous things. Another kernel capability that you can take advantage of is to limit the container restarts to 5. You can that's not a kernel capability. That goes right in the Docker file. And you should use audit-d and not only use it, but read the logs after you start getting audit-d output. These are the references. If you only want to read one, then read the one about Hitler. That's Hitler does Docker. YouTube has proven it. So,
Yeah, I've seen that.
yeah, we talked about it before. I don't want to show it again. But yeah, that's. I did have a question slide, but then I reused it as references. So that's all I got. Anybody have any questions?
What's the last one there, Hitler?
It's a parody video of Hitler talking about the way you should be using containers.
Oh, okay.
It's taken from a movie where he's speaking in German, and so the subtitles are actually changed. It's really funny. It's really funny.
All right version of
Yeah. Ben, you there still?
Okay, so yeah, I switched off of that.
Okay.
And that's all I got. So yeah, I hope you got something out of it.
Does anybody have any questions?
It's audience participation time, so I'm kind of looking to hear everybody else's stories about how they like to.
Glenn, come here so you can speak in the microphone.
Yeah, I'm not a Docker guru or anything, and I just saw this thing about Gosu instead of sudo.
Yeah,
What is that?
Actually, I looked for that just like you did. I was like, well, man, that'd be cool. And I could not find anything about it.
I did the same thing, and I don't know much about it, but it looks like it's a re-implementation of sudo, but using Go as the language.
Oh,
I don't know, other than maybe they prefer Go as their platform to do things, but it may be that with Docker,
Gosu.
Yeah.
Gosu.
Yeah,
We
that's
got
all we know.
one more question here.
Obviously, the guy's a fan of the Go programming language, and so it's just a new thing. Apparently, it's better than sudo, and he likes it.
Yeah, re-implementation is always better.
It's always newer.
Yeah, it's always newer because the code has not been checked.
yeah, it's a new code, so there are less errors in it.
So this may not even be a Docker question. User nobody, is that like a special Linux user, or is that just some name that?
It's a standard. It's just a user that is pretty much blank.
Okay.
It has no shell, has no privileges. It's just a holder. It's a
Okay.
convention.
Yeah, I've seen user nobody used on NFS.
Some versions of Apache have been implemented.
Yeah,
Nobody.
Apache can run as nobody instead of the Apache uses yeah.
I have a question on Docker. Just you mentioned and they showed in the video where you bind. So you load the Docker image for Nginx, and you have the external port 80, and you bind it to internal port 8080.
Right.
What if you're running 2 instances of Nginx in 2 different containers on the same box? Let's say you're doing, more like kind of that traditional shared hosting, but you're maybe trying to limit the ability for that sharing to impact another group. How do you bind then port 80 there to another internal address?
I've actually done this with Atlassian, where you have you can have Jira working on one port like 8090 and Confluence running on 8080, and the way you do it is with IP tables. There's a pre-routing table in IP tables where you can say all this traffic that is coming from the internet gets routed to 8080 and everything else gets routed to 8090. But yeah, that's how you do it with the pre-routing table.
So, but let's say you had, and this is just out there, and one of the questions I had, and maybe you don't get an answer here, perfectly acceptable.
Mm-hmm.
But let's say you have 3 websites, www.a.com, b.com, and you all want them listening in standard 480 of the clients.
Yeah.
But you now want to traffic put it to the right. How do you?
Yeah, well, I'll have to dig into my. I'll have to actually work that one out and reply to the list, unless somebody here knows.
Yeah, I was thinking maybe like a reverse proxy or a proxy scheme.
Are you saying you have 2 Docker containers running, and the containers each think they're accessing port 8080?
Well, even if you had 8080 for one of them and 8090 for another, what is the component that directs traffic for this website or this whatever the internal port happens And while IP tables pre-routing could certainly do that with IP addresses, like unique IP addresses or unique ports,
Right.
I don't think it would look at like host records like you would if you shared virtual hosts in Nginx just running a core by itself, or an Apache virtual host.
Yeah. I think the answer that he gave you is right. I think I view it a little differently. I mean, yes, Docker on the host sets up the IP tables, and I haven't really looked at that much, but I think it works exactly as you explained. But if you're running Docker, like doing the Docker run commands, then you just give it a host port and tell it what guest port to map to it. I mean, map it in the run command. You just say 80 on the host becomes 8080 on this guest. And so you have, all your guests could have port 8080 doing something, and you could map them to like port 80, 81, 82 on the host. And it happens through IP tables.
Well, my question is before that. So you hit basically what, host? Or do they each keep their own IP address? Because so somewhere you're going to have www.a.com resolving to an IP address, which is probably the IP address of the host, right?
Right.
So that's a single port 80 that is accepting traffic from 3 different websites. And how does Docker determine which internal port one of those pieces of traffic?
Yeah, where we run, Docker doesn't do that. The firewall does that. It sends it to different ports on the host. And then the different Docker containers listen to the different ports.
Yeah. I'm trying to mimic what you might want to do in a shared hosting environment where you've got one web server and you want to provide multiple, or one physical hardware and you're trying to provide multiple websites.
Yeah, I don't know how that works ultimately.
Yeah, it's an interesting question because it would seem to me that box would only have one IP, and it would just split out the traffic to these separate containers based on the internal IP that the box would allocate. So A.com and B.com and C.com would all seem to have the same IP address to the user, which is probably not what you want.
Well, no, you probably care about that.
Yeah.
Because that's traditional shared hosting.
Yeah. Yeah. Okay. All right. I guess it could work.
I don't know. I'm just curious.
Yeah.
I haven't dove too far into Docker.
Yeah. I just like having the tiniest amount of code running in a container as possible, and I also like the fact that all the containers that are on your host have to use the same kernel, and that's exactly what you want in an enterprise environment. Because it's real easy to have a whole bunch of boxes over here running on 3.8 and another bunch of boxes over here running on 4.1. And, hey, how did that happen? But with Docker, it's a requirement. Everybody's got to be running the same kernel. Okay, good, great. Okay, any other questions?
None here.
Okay,
Thank you, Ben.
welcome.